Good morning, everyone. This is page morning. You watch it whenever you want to watch this video. It's page 431, and we are marching forward with our conversation on chords inside circles. Now, I've gone on ahead and just completed the whole thing. So maybe at any point in this video, pause, rewrite, scrub back so that you can capture all the information that you're missing. And also have a highlighter, because when we're working through the information of this one, it's good to have the different colors, have the things that you're going to need in order to kind of keep track of what's going on. So I'm going to bring up the highlighter tool right now as well. And really, it's all written out from here on the screen. So I'm going to highlight key things that I think you need to make sure that you also mention. Okay. Activity 1, prove the converse of the statement that if you have chords that are the same distance from the center, then those chords must be congruent. So maybe with a, we think we green highlight for the prove. We're gonna prove that CH and DR are the same distance, all right? So CH and DR are going to be measured as equal congruent statements. We gotta get there though, we gotta get to that point. If you flick back to the previous page, you'll see a lot of similarities between what was done on page 430 with what we're doing on page 431. Okay, let's start off with the fact that the given information goes in the statements and reasons. So they're telling us that OE and OI are equal. We should probably at least highlight OE and OI. Gonna work the tool here to make it work the way we need to. Because they're congruent, that therefore means equidistant. At some point, we're gonna have to say equidistant from the center, which is true. CH and DR are equidistant from the center point. That's what we get. We also have this information. We have, maybe I'll highlight it in red. We have OE is parallel to CH. So if OE is here and CH is here, parallel really just means we want you to call attention to the right angle that exists right at that box. And also the same is true for OI, DR, that there is a right angle box right there. Both of those statements. It's strong highlight color there. We'll use the green and the red and the yellow throughout the 2-column proof. So this is a good spot for you to actually pause the video, for me to go ahead and maybe center up. Is that visible? I think it looks pretty decent. Okay, pause the video and start writing, and then come back to the video so that I can talk about it, all right? Pause right here. All right, welcome back if you did. Okay, if not, here it is, pause at any time. So OE equals OI and OE and CH and OI and DR. Those are all of our statements from the proof that were given to us in the prompt. That's step 1, it's given, always given. Next is step 2, says we gotta do some construction. And so that actually happened on page 430. If you flip back or look to the previous video for this one, that there is an element of connecting the points that wasn't there in the diagram, but we need to do as part of our representation here. So let's connect, we'll use the draw tool. Let's connect with blue. OH, OC, come on now. This is the way I'll do it. Those are really dark, bold lines, all right? But there they are. This is actually step 2 in the proof. We're actually drawing in OH, OC, OD, and OR, and these are all going to be congruent lengths because they're radii of a circle. That's given to us by construction. I've literally constructed it right here, and there isn't any proof behind it. I'm just using points that are inside circles making radii of circles. Doesn't that mean then that OE and OI are congruent? I mean, if they're the same distance, so bring back annotate, bring in some highlight. This is where it's all written out, and now we need to make sure we're processing the 2-column proof and filling it out, but also knowing why each step is filled out. So this is yellow because definition of congruent segments. It was said up there. We need to use it. Next up, OH, OC, OR, and OD are all congruent, and I'm going to use blue highlight because it was blue highlight from, let's get rid of you. I'm gonna go like this. All right, I'll go like that. All right. Those are the blue statements, the blue line segments up above. And so all radii in a circle are congruent. That's another statement that's being used. Please bring the color into your work. Now, OE and OH, OE, this statement right here about these angles being right angles, it's because of the fact that we are using perpendicular. So our statement, back up, just make it all one big one, there we go, is by the definition of perpendicular bisector. The perpendicular lines, not bisector, perpendicular lines create right angles. We got to make sure we have that. Now, next up, if you have right angles and those right angles form triangles, then you have right triangles. So this is an extension of what was said in red. I'll just highlight the whole thing because there it is. We know that those triangles are congruent for a mixture of yellow and blue and red. So this one's a little bit tougher. I'll just go boom for a color and for a color. It takes all three statements in order to make that statement 7. And once you make statement 7, you get statement 8. The fact that on those 4 congruent triangles, HE, EC, DI, RI, they're all congruent to each other because we have congruent triangles, and corresponding parts of congruent triangles are congruent. Now, if they are congruent line segments, then they must also be equal measures. So we're not using the M with the line on top like Mathia does, but we are acknowledging there's another way that you can write equality of length of line. We can say without the letter, without the congruent little squiggle on top. Continuing on, we get further on down saying, okay, then if you add segments together, like if you add segment HE plus segment EC, adding these two segments together creates one long segment, HC. It does the same for RD. So adding segment pieces together gives us a longer segment. And because everything is floating with congruence all the way through the proof, therefore, those segments are actually equal to each other. CH and DR are congruent. If chords of a circle are drawn so that they are equidistant from the center of the circle, then those chords must be the same length. Thank you for watching this video. You are awesome. I appreciate you being here, clicking all the way through. Like, comment, and subscribe. Don't forget to leave a like, whatever they say, I don't care. Thank you. You're awesome. See you in the next video. Bye.